One of the most obvious forms of capacity wastage is idle time. Idle time happens for two reasons. First, by definition, every resource that is not the bottleneck will have some excess capacity compared to the bottleneck. This will translate into idle time. Second, if you're currently constrained by demand, even the bottleneck resource will have some idle time. In this session, we'll talk about ways of reducing idle time. First, we'll talk about the concept of line balancing. Line balancing is about sharing the work equally among the resources in the process. We'll then talk about scaling up the process capacity as demand potentially fluctuates. We can add or subtract workers from the line, adjusting our capacity and saving us from incurring idle time when the demand is low. Let us revisit the subway example. Earlier on, we computed that the labor content at the subway line was 120 seconds per customer. Now assume that we have 80 customers arrive every hour. Previously, we had determined that the processing times for the three operators were 37 seconds per customer at station 1, 46 seconds and 37 seconds at station 2 and 3 respectively. The idea of line balancing is to divide up the work evenly. So we want to take some of the work from worker 2 and spread it to worker 1 and 3. A powerful way of doing this is by first reminding ourselves of the flow rate that this process has to operate under. This is the idea of takt time. Takt time determines that we have to produce a unit every 45 seconds to keep up with demand. After all, every hour, 3,600 seconds, we have to make 80 units. So 45 seconds per unit is the takt time. Takt is a word that comes from the German word Takt, which stands for the beat of the music. In the process, everybody has to dance to the beat of demand. Every person should serve a customer and move it forward to the next station at a speed of 45 seconds. Assuming a perfect line balance, the takt time also helps us find how many people we need to staff in the line. 120 seconds of labor content divided by 45 seconds of takt time gives us that we need, rounded up, 3 people to do the work. Now, admittedly, this is an ideal calculation. I cannot have worker 2 put half of a tomato on the sandwich and worker 3 put the other half. The tasks often cannot be divided as easily as second by second. However, I find that starting with such an ideal calculation, that's why it's called the target manpower, is often very eye-opening, and it reminds you of the true productivity improvement potential that there exists in the process. It is then up to you to design the tasks in the process so that line balancing will become possible. Now imagine that demand picks up to 160 customers per hour. The takt time changes. We now have to divide 3,600 seconds in an hour divided by 160 units per hour equals to a new takt time of 22.5 seconds. So instead of serving a customer every 45 seconds, we're serving a customer every 22.5 seconds. The takt of the music has picked up. This is also reflected in our target manpower calculation. We're dividing the labor content, which has stayed unchanged at 120 seconds per unit, by the new takt time and see that in order to fulfill this increased demand, we have to increase our staffing level from 3 to 6. Let's summarize our calculation for line balancing. Line balancing starts with computing the takt time. It's the demand that drives everything as we are executing the process. Once we have the takt time, we take the various tasks that make up for the flow unit and we will divide them among the workers so that the total processing time for each worker is less than the takt time. You continue to do this until all other tasks are assigned to the workers. As you're doing this, you try to keep the number of people at a minimum. This can be written as quite a fancy mathematical problem, but oftentimes, at least for smaller scale problems, it can be just tweaked by trying this out a couple of times. Now, I want you to think about the following question. What happens to labor utilization as demand goes up? To see the effect on labor utilization, first ask yourself what happens to takt time as demand goes up. More demand means a shorter takt time. This makes balancing the line harder. To see this, think about the opposite effect. Think about the case of balancing a line with just one person. Balancing a one-person line is trivial. That person will have little idle time and we have a very high labor utilization. As you go in the opposite dimension, you add more people to the line and reduce the takt time, line balancing becomes increasingly hard. Finally, I want to acknowledge that the world is certainly not one big math problem to solve. The same holds for the case of line balancing. Instead of finding some fancy algorithm along the lines that I previously described, in practice line balancing is often done dynamically by walking around and looking where inventory piles up. We can then go and reassign either people or tasks so that the flow goes faster. This typically starts by looking at the bottleneck resource. Keep in mind that any activity that will move away from the bottleneck has the potential to increase capacity. Balancing non-bottleneck steps, however, is often a fruitless task. Once you understand line balancing, you can also start dealing with changing demand. Consider the demand trajectory shown up here. We will refer to this pattern as seasonal demand. Seasonal demand and demand variability will be discussed more in the responsiveness module, but for now, let's just observe that the demand changes predictably over the course of the day. The first thing that you do is you level the demand. You want to avoid to change your takt time or your staffing level every minute by minute, and so you come up with a level demand where you hold the demand for an hour as fixed. This is arguably an imperfect approximation, but better and more practical than changing your staffing level every minute. Once you have a level demand, you translate that into a takt time. Remember, more demand means a shorter takt time. Finally, you take this takt time and you translate this into a manpower calculation. This is done based on the target manpower calculation that we reviewed earlier on. As you see in the example here, in the low period settings, I can get away with 3 workers carrying out the 6 tasks. Once demand picks up, my takt time gets shorter and I have to bring in extra people. This helps us to scale up and down the process as demand changes. Capacity tends to be fixed, while demand changes often over time. This leads to temporary mismatches between supply and demand. Customers wait or resources are idle. The ability of an operation to adjust its capacity and scale it up and down in response to a varying demand is a form of flexibility. Most operations create their flexibility by using either temporary workers or by using their workers overtime. In this session we saw how a takt time can be used to drive the demand down into the operation. We saw how we can use takt time to compute the staffing level required to run a process, and we also saw how takt time can be used as a form of line balancing.